No.
We are going to talk of something called a derivative.
Yeah.
This will be a very important word for you calculus people next year.
No. I don't even know what that word means.
The derivative. What is this?
I don't know. That one thing. Well, it looks
The limit of the difference quotient. Okay. Okay. Write this down because you need this notation and I will tell you what it means. Write this down because it's the notation. The derivative of f at x is given by this. Provided the limit exists. If the limit does not exist, then we don't have a derivative there. Okay? All right. You basically are seeing f prime of x, right? Okay. F prime of x is just our notation for the derivative of x. Okay? So our function is f of x. Our derivative is f prime of x. Okay? And the derivative, okay, what is the limit of the difference quotient give us? Ah, so what does the derivative tell us? Seriously.
Why?
Okay, so all that work that you were doing yesterday finding slope, you were finding the derivative. The slope at where though? At a particular point. Okay. Derivatives will be huge next year. Okay? All right, so we're going to find the derivative of this function. So first of all, what is our notation for a derivative? And we know that it's going to be the limit of the difference quotient. So how do I write f of x plus h?
3 x plus h squared minus 2 x plus h.
There's f of x. Is everyone okay with it? Minus. All right. We're going to have to do some intense algebra here, huh?
Nah.
Okay. The limit of the difference quotient will always be h approaching 0. Okay, now we're smart kids. X plus h the quantity squared. What is it? Okay, I heard lots of mumbling, but I heard it from a few different people. X squared plus 2xh plus h squared.
Yeah.
We know that. Can we multiply that by 3 all at once?
Maybe.
3x squared plus 6xh plus
3.
because it'd be 2xh.
We're not smart kids. 3 times 2 is 7.
Here, what do we have?
2x minus a 2h. Sorry.
And then?
Minus 3x squared plus 2.
Good.
With
All
the
right.
Cancel.
What cancels?
2x squared.
Okay, so our 3x squared,
2x.
our 2x's.
That appears to be it.
Okay. to do now?
Take out an H.
Take out an H. Factor out an H. So the H's cancel. Okay. Now can we evaluate our limits? Direct substitution, plug 0 in for H. That is what we call our derivative, and it represents the slope at any point on our function f of x. We're bringing it all together. Hold on, what does the derivative represent? Slope at any point.
Oh, wait, we're allowed to do that now?
Wait, why is
We weren't allowed to do that before.
What is this?
Oh, because of
This is a line with a constant slope of, what's the slope at any point? 4. Our derivative is 4. I will let you make that shortcut.
Really? Because we're not allowed to do that. That's awesome. So that's what you get when you divide by 0?
No.
All right, last type of problem. We've been talking about these tangent lines and we've been finding their slope, but we haven't actually written the equation for the line. Oh. So, we're going to actually go through the process of writing the equation of the tangent line. Not just finding the slope, but actually writing the equation. Okay? So, first we need what? Okay, we need slope, correct? Okay, so first let's find our derivative. So the limit as h approaches 0, f of x plus h.
2 x plus h squared plus 3.
Minus f of x, remember, subtract the entire quantity.
All over h.
Okay? Now, we can do some math in our head. We know what x plus h, the quantity squared, is. We just did it in the last example. Multiplied by 2 would become what?
2x squared plus 4xh plus 2h squared.
Is everyone okay with that shortcut?
Plus 3 minus 2x squared minus 3 all over h.
Okay?
2x.
The 2x squareds cancel, and the 3's cancel. Okay, so we need to factor out an h. Plug that 0 in, and we have
4x.
because h is 0. Okay, so our derivative is 4x, which means our slope at any point is 4x. We are worried about the 0.15. Okay, so our x value is 1. So if I want my slope, I'm going to plug 1 in to my derivative, and our slope is 4. How do we write the equation of the tangent line? Okay, this gives us what? And we have a point
that means it's 4x.
How about point slope form, people?
Yeah, I mean, sure. You could do that if you wanted to.
Point slope 4. Y minus y equals slope times x minus x.
Or we could just leave it like that.
I can't remember what the book asks. If it wants it in slope-intercept form, what would we have to do?
Distribute.
Distribute.
And then add 5.
So this would be 4x. This becomes minus 4.
Plus 5.
Okay? In calculus, for sure, we will leave them in point slope form. I can't remember what your book asks. And there you have it, ladies and gentlemen. You never have to listen to me teach you a new lesson this year. This school year. Calculus.